Welcome to the deep dive. Today we're plunging into, well, a really fascinating 60-year-old puzzle in paleoanthropology.
Yeah, it's a big one.
It really is. We're talking about the true age of the Petralona cranium, one of the most crucial human fossils ever found in Europe.
Absolutely key.
So our mission today, let's try to unravel this mystery using the latest science and then, explore what its actual age means for how we understand human evolution right here in Europe. We're heading virtually, at least, to the Petralona Cave in Greece, a place that's seen its fair share of debate over the years.
Oh, definitely. You could call it a classic cold case, really. For decades, this fossil has been caught in this storm of conflicting data, different viewpoints.
Right.
So yeah, this deep dive is a great chance to sort of cut through all that noise, give you a clear picture of what science now thinks is the most reliable age for this really vital piece of the human story.
Okay, let's unpack this enigma then. The discovery itself that was back in 1960, right?
Yeah, 1960. Found in this small chamber inside the cave. They called it the mausoleum. Kind of fittingly, I suppose.
Yeah, near Thessaloniki in Greece. And this wasn't just like a fragment, it was a nearly complete cranium.
Which is why it's so important. Its position in European human evolution is just central.
And looking at its features, its morphology, it stands out, doesn't it? It looks, well, more primitive than us, Homo sapiens, and also more primitive than Neanderthals.
That's right. It actually shares quite a few features with the cowboy cranium, the one from Zambia.
Okay, so Africa and Europe connection there?
Potentially, yeah. And it's usually classified, though people still argue about it, within Homo heidelbergensis. But the sensillado bit is important. That means in the broad sense. It's a bit of a catch-all sometimes.
Gotcha. So a key fossil, but right from the start, there was this major problem with dating it.
Exactly. That's the fundamental challenge that just dogged this thing for decades, how it was found.
How so?
It was discovered without any stratigraphic context. That's the crucial phrase.
Meaning it wasn't neatly buried in layers of sediment that you could date.
Precisely. Imagine trying to solve a puzzle with half the pieces missing. Reports say it was just cemented to the chamber wall.
Wow, really?
Yeah.
Just stuck there?
Apparently so.
Yeah.
Which immediately made it different from other key sites, like, say, Conde-la-Rago in France, where you have fossils nicely embedded in datable layers.
Okay.
This lack of context made those traditional dating methods, well, incredibly difficult. Almost impossible at the time, really.
And that difficulty, that's what sparked the decades of debate, the scientific battleground.
It really kicked off in the early 1980s. You have to remember, this was kind of a pioneering time for using these physicochemical dating methods in caves, these karstic environments.
Right, new techniques being tested out.
Exactly. And frankly, a lot of those methods were still pretty experimental, which, helps explain some of the wildly different results people were getting.
How wild are we talking? What kind of age ranges came out initially?
Oh, it was messy. I
Yeah.
mean, truly messy. You had results coming back from all sorts of samples, bits of calcite, bone fragments, quartz, cave sediments. And the ages were just all over the map. We're talking a huge range, something like 170,000 years all the way up to maybe 700,000 years.
Whoa, that's enormous.
It is. You had researchers like IKEA suggesting ESR dates on calcite from that chamber ranging from like 70,000 to 700,000.
Okay.
Then Hennig and his colleagues analyzed calcite stuck to the cranium and bone fragments, suggesting maybe 160 to 240,000 for the calcite, around 130 for the bones.
So quite different.
And then Schwartz's group used U-series dating, getting ages from 272,000 up to basically too old to measure. But they proposed a finite age of 440,000 for one sample.
So just complete disagreement.
What are chaos, scientifically speaking? There were these really intense back and forth published in Nature. You had Polianos arguing for over 700,000 years old, based partly on animal bones found elsewhere in the cave. Lurizzi's arguing it couldn't be older than 250,000. And Hennig sticking to his guns around 200,000, plus or minus 40,000. They even argued about whether a whole skeleton was found.
Good grief. It sounds like nobody could agree on anything.
Pretty much. And adding to the confusion was this major issue. The link between the cranium itself and other things found in the cave, like certain animal fossils, the so-called cranian fauna, or even claimed stone tools.
Yeah.
That link cannot be firmly established. You can't definitively say they belong together, that they're the same age.
Because the skull wasn't found with them in a clear layer.
Exactly. It got even crazier. Some teeth initially thought to be hominin. Turned out they probably belonged to a bear, an Ursus.
Oh, wow. Okay.
So you've got no clear stratigraphy, no definite link to other finds, and these early dating methods are still experimental. It meant no consensus was possible. It led people like Wintle and Jacobs back in '82 to basically say the material was, quote, unsuitable for some of the techniques used.
Okay, so after decades of this gridlock, really, how did we finally get a breakthrough? What changed?
This is where the story gets really interesting. It's the new research led by Falgueres that came out very recently. They set out specifically to try and resolve this puzzle once and for all.
And how did they approach it differently?
Their critical move was to focus only on the calcite, the mineral crust, that grew directly on the cranium itself.
Oh, okay. Not just any calcite from the cave wall or floor.
Precisely. They argued that this was the only sample able to provide crucial information on the age of the fossil. Makes sense, right?
It does, and the method. Still U-series.
Yes, U-series dating, but using much more advanced technology. Things like ICP-MS inductively coupled plasma mass spectrometry, both quadrupole and multi-collector types.
Okay, that sounds high-tech.
It is. These techniques, run in top labs like Nanjing Normal University and the Paris Museum, are incredibly sensitive. They can measure the uranium and its decay products with way more precision than the old methods, like alpha-ray spectrometry.
Much less uncertainty, then.
Exactly. Increased sensitivity, increased precision.
So, the moment of truth. What age did this new focused analysis give?
Okay, here it is. The research gives a finite minimum age of 286,000 years ago, plus or minus about 9,000 years for the cranium.
286,000 minimum.
And crucially, this age comes from the inner part of the calcite crust, the white layer right against the bone, the first bit that formed. The outer, dirtier layers were contaminated, so they couldn't be reliably dated.
Got it. So 286 call is the secure minimum age for the skull itself based on that first calcite layer. And that's significantly older than some of those earlier estimates like Hennig's 160-200 call.
Yes, quite a bit older than that particular estimate for the crust. But here's the real kicker. The study found that this calcite on the cranium, the stuff dated to 286,000 years ago. It is not the same age as the calcite veil on the cave wall where the skull was supposedly stuck.
Wait, really? So the skull wasn't cemented to the wall by calcite that formed at the same time?
That's what the data shows. The calcite on the wall gives much older ages, around 510,000 years for the top layer and potentially over 660,000 years deeper inside.
Wow, so that completely contradicts the idea that the skull calcite and wall calcite were the same stuff, same age.
Directly contradicts it. Previous analyses had suggested they were similar chemically, but this new, more precise dating shows they formed hundreds of thousands of years apart. This is a total game changer for understanding how the skull got there.
Okay, so if the skull calcite and wall calcite aren't contemporary, what does that mean for how the cranium actually ended up in the mausoleum chamber?
Well, it opens up two main possibilities based on the new dates. Possibility one, if it was somehow attached to that ancient wall calcite, well, then its actual age has to be somewhere between when the wall calcite formed, maybe around 539,000 years ago.
Right, the older date.
And when its own calcite coating formed, around 277,000 years ago, using the lower end of the error margin for simplicity here. That's a big window, but it puts an upper limit on it.
Okay, and possibility two.
Possibility two, which seems much more likely now, is that it wasn't attached to the wall in that way. If that's the case, it must have arrived, been deposited somehow in the mausoleum chamber after about 410,000 years ago.
Why 410,000?
Because that's the age they got for a stalagmite floor in a nearby passage, the Dardanelles Passage. That floor sealed off older sediments underneath it.
Ah, so the skull had to arrive after that floor formed?
Right, and before its own calcite coating formed around 277,000 years ago. So a window between roughly 410,000 and 277,000 years ago for its arrival in the chamber.
That narrows it down considerably compared to the old debates. Can we piece together a plausible story for the skull's journey now?
We can build a much better hypothesis, yeah.
Yeah.
So picture this. First, way back, maybe around 539,000 years ago, you have calcite forming on the cave walls, ancient stuff.
Okay.
Then later, around 410,000 years ago, this thick stalagmite floor develops in the Dardanelles Passage, sealing off whatever fill was below it, maybe leftovers from a hyena den, perhaps. Now, the crucial part. The Petralona cranium arrives in the mausoleum after that 410,000-year-old floor formed. The thinking is, it couldn't have gotten coated in calcite the way it did if it was down in that messy hyena den fill. It must have come later.
Makes sense. It arrived in a cleaner phase, maybe.
Possibly. And then finally, around 277,000 years ago, this calcite coating starts to form directly on the skull, which interestingly, is a bit before the last known phase of stalagmite floor formation in that Dardanelles Passage, which happened around 230,000 years ago.
Wow. That timeline really highlights how complex the cave's history must be.
Oh, incredibly complex. And the new dating of other sediment sections, like the B section, confirms this. They found layers dating way back to MIS 13, that's marine isotope stage 13, around 535,000 years ago, right up to layers as recent as 43,000 years ago.
The sediments washing in and out, calcite forming at different times. No wonder the early dating was so tough.
Exactly. A very complex depositional history, as the researchers put it.
Okay, so the big so what question. We have this new minimum age, 286,000, 9,000 years. What does this mean for the bigger picture of human evolution in Europe?
This is where it connects back to everything else, this age. It basically rewrites a key part of the story for the Middle Pleistocene in Europe.
How so?
Well, it provides further support for the coexistence of this type of hominin, this Homo heidelbergensis-like population, alongside the ancestors of Neanderthals, the ones evolving into Neanderthals, during this later Middle Pleistocene period.
So they were living in Europe at the same time, different groups.
It strongly suggests that yes. And remember the morphology, the fact that Petralona looks more primitive than classic Neanderthals or us.
Yeah.
This new, firmer date fits perfectly with the idea that these Homo heidelbergensis populations, or something very much like them, persisted in Europe deep into this period, while the Neanderthal lineage was also taking shape.
Fascinating. So not necessarily a simple linear progression, but maybe multiple hominin types around?
Exactly. It adds complexity. And think about that connection to the cowboy skull in Africa again.
Right, the similarities.
The similarities in the face and the overall skull shape between cowboy and Petralona, plus the fact that neither of them show those really distinct specialized Neanderthal features, the apomorphies, especially in the mid-face. It suggests that maybe these heidelbergensis-like populations in Europe and Africa remained closely related. For a long time during the Middle Pleistocene, they were kind of doing their own thing, developing alongside but separate from the lineage that led directly to Neanderthals.
So it complicates the family tree, making it maybe bushier.
Precisely. It really forces us to look again at that whole muddle in the middle, that complex period of Middle Pleistocene diversity. How did these different groups interact? How separate were they? This Petralona dating adds a really solid data point to that ongoing discussion, especially for Europe.
So this deep dive into Petralona, it hasn't just solved, or at least largely solved, a decades-old dating mystery. It's actually shifting our understanding of who was living in Europe and when during a really critical time.
Absolutely. The power of these modern dating techniques, applied carefully to the right samples, has finally allowed us to place this incredibly important fossil much more securely in our evolutionary timeline.
It really underscores the value of revisiting old questions with new tools.
It really does. And here's maybe a final thought for you to consider. This one skull, now more precisely dated, doesn't just tell its own story.
Right.
It highlights how interconnected human evolution likely was across continents, even back then.
Yeah.
And it really pushes us to keep questioning, keep reevaluating the branches of our family tree. Makes you wonder, doesn't it? What might other fossils, the ones that are still enigmatic, reveal when we can finally apply this level of scrutiny to them?
A fascinating question to leave us with. What other secrets are waiting in the stone? Thanks for walking us through that.
My pleasure. It's a fantastic example of science chipping away at a mystery.